Top 10 gemstones found in ancient trees. Long before diamonds touched the Earth's surface, ancient forests were already producing their kind of treasure. Gemstones formed from trees. These aren't just fossils, they're crystallized time. Each of these stones was born from bark, sap, and decay. Some glow with fire. Some hold entire ecosystems. And some are so rare their value now surpasses gold by the carat. These are the top 10 gemstones born not in caves or mines, but inside the bones of forgotten forests. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10. Ammolite. When fossil shells met fossil trees. Rare is the gemstone that bridges ocean and forest, but ammolite forms where ancient ammonites and buried trees once converged, deep within the shale beds of prehistoric wetlands. As inland seas covered modern Alberta in the late Cretaceous, drifting ammonites settled among coastal forests, rich in conifers and cycloids. Over time, these trees decomposed beneath silt, releasing organic acids that altered the chemistry of the surrounding seabed. Those acids contributed to the mineralization of ammonite shells, enhancing aragonite layering and eventually giving birth to ammolite's vibrant surface. Though primarily a fossilized marine shell, ammolite's fire owes a hidden debt to the resin-rich vegetation around it. The same anoxic conditions that preserve logs and stumps also slow decay in aragonitic fossils, allowing thin layers to stack unbroken. These layers, only microns thick, create an optical interference that yields full-spectrum iridescence. Ammolite is mined from the Bearpaw Formation, where tree fossils and ammonite remains are often found within the same stratigraphic seams. Calibrated cabochons ranging from 10 to 25 carats can command $500 to over $2,500, depending on color intensity and structural stability. This is not just a gem of ancient oceans. It is a gem born from the long-forgotten interplay between forest decay and marine life. A brilliant afterimage from the meeting of root and tide. Ranked 9. Agatized Wood. Roots that became quartz. Trees once stood for centuries in forests that thrived before mammals' age, building layer upon layer of life in each passing ring. When volcanic eruptions or flood-borne sediments buried them, those trunks didn't decay, they crystallized. What survives today is known as agatized wood, a gemstone forged when silica-rich waters infiltrated the cells of ancient trees, slowly replacing organic material with banded chalcedony. Unlike simple petrification, this process preserves not just form, but energy, color, movement, and complexity, which are locked into a fossil. The banding in agatized wood reflects the tree's vascular patterns, but is now refracted through iron reds, copper greens, and smoky grays. In some pieces, the wood grain is still visible beneath translucent quartz. In others, the transformation is so complete that it appears more like marble than timber. American deposits, particularly from Arizona's Triassic forests, yield slabs up to 10 inches wide, used for sculpture, decor, and jewelry. More minor cuts, around 200 carats, fetch $150 to $800, depending on mineral saturation and clarity. Agatized wood is not simply a gemstone formed on the earth. It is the aftermath of ancient forests choosing permanence. Each piece is a fossilized decision between collapse and crystallization. Ranked 8. Burmite. The resin that outlived its forest. Roughly 100 million years ago, vast coniferous canopies dominated northern Myanmar. When these ancient trees were wounded by storm, insect, or age, they released thick and fragrant resin. In most forests, resin fades. In these, it fossilized. This hardened substance is burmite, one of the oldest and most scientifically valuable forms of amber ever discovered. Trapped within its orange-gold body are not just air bubbles or plant fragments, but fully preserved microfauna. Ants, feathers, beetles, and even the occasional vertebrate tissue. These were not added later. They were caught mid-flight, mid-movement, and mid-moment as the forest sealed itself shut. Burmite's transformation began under intense geological pressure, within sediment layers shared with petrified wood and fossil roots. Some specimens are directly associated with lignified fragments, where resin flowed alongside decaying bark in buried trunks, fusing into amber inches from fossil wood. Gem-grade pieces above 30 carats range between $500 and $2,000, though museum-grade inclusions have reached well beyond six figures at auction. Today, the material emerges almost exclusively from the Hukong Valley, a site as politically complex as it is geologically rare. Burmite does more than preserve life. It preserves the chemical memory of ancient trees, recording what they witnessed and what flowed from within. Ranked 7. Bog Oak, the carbon memory beneath the marsh. Thousands of years before iron tools, written language, or city walls, oak trees dominated the wetlands of northern Europe. Their trunks sank not by storm, but by weight, submerged into peat bogs where air could not reach, and time moved at the pace of decay. Over centuries, these oaks absorbed minerals from the bog's acidic waters, transforming without crystallization. The result is bog oak, not petrified but preserved in carbon-rich silence, its wood darkened to near black, its grain lines enhanced by pressure instead of heat. Archaeological finds often reveal bog oak alongside stone tools and Bronze Age relics, buried together in the same stratigraphy. In some river valleys, partially fossilized oak trunks measuring over 12 feet long have been pulled from excavation pits, their cores still dense enough to polish into gemstone-like slabs. Small pieces, 2 and 3 inches across and ranging from 300 to 800 carats, are stabilized and cut for high-end jewelry and wood inlay. Pricing varies with age and luster, with museum-grade pieces selling for $250 to over $1,200. Bog oak is a product of oxygen deprivation, tannic chemistry, and patience. Its elegance lies not in sparkle, but in density. A structure once shaped by photosynthesis is now worn in matte black rings, knife handles, or heirloom pendants. Not every gemstone begins as a stone. Some begin as trees that refuse to disappear. Ranked 6, Copal, resin that never let go. In tropical lowland forests where dense canopies meet monsoon rain, some trees bleed resin in moments of trauma, cut, cracked, or attacked. That resin drips, hardens, and sometimes escapes decay, not by age but by burial. If the conditions are just right, it becomes copal, a fossil in the making formed entirely by trees that lived and died in tropical silence. Copal is often no older than a few thousand to a few 100,000 years. Yet in its clarity, it behaves like a time capsule, preserving the forest's smallest lives. Winged beetles, pollen grains, and even fragments of leaf cuticles. Copal is found in soils beneath extinct or felled tree zones, particularly from Colombia, Madagascar, and parts of East Africa, where shifting sediment layers briefly protected resin flows before partial fossilization. In these zones, fossilized wood, bark, and resin often coexist, creating a layered archive of once thriving ecosystems. Specimens ranging from 30 to 70 carats are valued primarily for what they hold. Inclusions of rare insects or arachnids can raise prices from $40 to over $300 depending on size, visibility, and integrity. Though softer than authentic amber, registering just 1 to 1.5 on the Mohs scale, high-clarity copal remains a collector's favorite. Copal offers no illusion of permanence. It is resin caught mid-transformation, a forest's unfinished attempt at immortality. Ranked 5, Silicified palm wood, fossil code from a vanished swamp. Roughly 100 million years ago, the coastal plains of North America were swamps ruled by ancient palms, plants not with rings like oaks, but with vascular bundles scattered like constellations across their trunks. When these trees fell into waterlogged soils, their bodies avoided decay not by accident, but by the consistent saturation of silica-laden groundwater. As the plant's soft tissue faded, silica crept in. What formed was not just a fossil, but a mineral map, dots, ovals, and lines marking where each vascular thread once carried sap. This became silicified palm wood, a gemstone that encodes biology like an ancient signal etched in stone. Found most abundantly in Cretaceous sediments across Texas and Louisiana, many specimens are excavated beside fossil roots, leaves, and even pollen grains. proof that this wasn't just a tree but part of a living wetland system. Under the microscope, each cabochon reveals a unique geometric rhythm. Some show dotted clusters like digital code, others swirling ovals as if the tree were frozen mid-growth. Cabochons between 30 and 150 carats can fetch $40 to $400, especially when the contrast between bundle and matrix is sharp. Rarer material, infused with iron for red hues or manganese for black, has become increasingly difficult to obtain due to mine closures and erosion. Where most fossil woods preserve form, this one preserves function. An anatomical diagram fossilized in motion, carved not from branches, but from the systems that once kept them alive. Ranked 4, Opalized Wood, when saplings became spectra. Deep beneath the volcanic plains of prehistoric Australia and North America, fallen trees once rested in silence. Ash and sediment sealed them, but time did not erase them. It rewrote them. What emerged millions of years later was opalized wood, where the structure of a tree remained, but its chemistry was transformed. This transformation was not superficial. Silica-rich groundwater infiltrated every cell wall, replacing lignin and cellulose with hydrated silica. In rare geological alignments, that silica formed not into quartz or chalcedony, but into precious opal, capable of diffracting visible light. Unlike most opals, which form in cavities or seams, these grew within tree trunks. Growth rings, bark textures, and even vascular channels persist. Only now do they refract green, blue, violet, or fiery red, depending on the angle and composition. Some Lightning Ridge or Eastern Oregon specimens retain visible wood grain and full-spectrum iridescence, a collision of biological order and optical chaos. Specimens between 25 and 35 carats, especially those with uninterrupted bands of fire, command $1,000 to $3,000, though larger museum pieces are essentially priceless due to rarity and fragility. What sets opalized wood apart is its color, brightness, and origin. It is one of the few gemstones in which structure predates sparkle, where what shines today was once built to grow, not melted, not mined. This gem was grown, then transformed, the roots of a forest reborn as spectral stone. Ranked 3rd, Petrified Wood, the forest cast in stone. Once, rivers carried fallen trees into floodplains, where they would not rot but fossilize. Beneath layers of volcanic ash and mineral-rich water, these trunks were transformed cell by cell into stone. The result is petrified wood, one of Earth's most widespread and visually diverse organic gemstones. Petrified wood typically retains exact anatomical detail, from the bark ridges to the innermost growth rings. Silica, calcite, pyrite, or other minerals slowly infiltrated the plant tissue over millions of years, hardening into a dense matrix that mirrors the original structure. No two pieces are identical. Some resemble polished mahogany, and others appear like banded jasper in tree form. Central deposits span from the Arizona petrified forest to Indonesia, Madagascar, and Argentina regions. In the U.S., slabs over 12 inches wide have been cut from fossil logs over 200 million years old, now used as tabletops, jewelry components, or museum specimens. Smaller polished pieces, 100 to 300 carats, can range from $50 to $600, depending on color, clarity, and origin. Some specimens contain hues influenced by trace elements: manganese for pinks, iron for reds, and chromium for greens. When sliced and polished, they reveal a story told in rings, a calendar of centuries fossilized in quartz. Petrified wood is not simply ancient. It is a life remembered in stone, a forest frozen mid-breath, preserved with geological precision. Ranked 2, Jet, pressure-wrought relic from Jurassic trees. Over 180 million years ago, coniferous forests stretched across the landmasses that would become Europe and Asia. Within these ancient woodlands, certain trees, particularly members of the Araucariaceae family, fell into wetlands rich in silt and mud. There, deprived of oxygen and buried under steady layers of sediment, their timber began a rare and irreversible transition, not into stone, but into a carbon-dense fossil. Jet is a mineraloid born not through crystallization, but through compression. Its source material was purely botanical, decayed wood subjected to immense geological force, gradually compacted into velvety black lignite. What survived is not petrified fiber, but compressed organic structure, still traceable to tree growth rings in its raw state. Most jets used today are sourced from the Whitby region of England, where fossilized logs are recovered from shale cliffs formed during the Jurassic period. Segments measuring 2 to 4 inches across are commonly carved into beads, pendants, and intaglios. When polished, the jet develops a warm, satiny luster with no crystalline reflection. It absorbs light rather than bends it. Jewelry-grade specimens weighing 50 to 150 carats range from $100 to over $800, depending on provenance and finish. Historically worn as mourning jewelry across Victorian Europe, the jet held symbolic weight, but its true significance lies beneath the surface. It is the echo of ancient forests pressed into permanence, not by mineral replacement, but by the sheer gravity of time itself. In the first place, amber, the resin that became time. 40 million years before the rise of modern humans, coniferous trees in the Baltic Basin stretched toward clouded northern skies. When their bark cracked, golden resin seeped outward, slow, viscous, and fragrant. It dripped from wounded limbs, entrapped small lives, and hardened in midair. Through the long rhythm of burial and pressure, what began as a tree's defense became the world's most ancient organic gemstone. Amber. This substance is not formed from minerals or metal, but from tree blood, once liquid resin exuded to heal, shield, and preserve. Buried in layers of sediment and clay, the resin fossilized not through replacement, but through polymerization. Its composition, rich in succinic acid and plant terpenes, records the chemical signature of vanished forests. Baltic amber, the most prized variety, originates from vast, extinct conifer species. Some pieces contain botanical inclusions, bark fragments, leaf hairs, pollen grains, while others house exquisitely detailed insects, still bearing visible antennae, legs, and wing venation. These internal archives, visible through walls of golden transparency, have redefined the paleobiology of entire ecosystems. Polished cabochons between 30 and 100 carats range in price from $200 to over $3,500, with rare pieces containing scientifically significant inclusions reaching into 6 figures. Top-quality specimens often measure 1 to 3 inches and are used in luxury jewelry and museum collections. Amber lacks a crystal lattice, cleavage planes, or refractive brilliance. Its power lies in stasis, a forest moment sealed by its tree, hardened through epochs and delivered intact to human hands. Before the first gem was mined from deep rock, nature was already shaping treasure from tree trunks. These gemstones, born from resin, fiber, sap, and silence, carry more than geological beauty. They have living forms that are fossilized in function. Every piece is a portrait of survival, a tree's final transformation, hardened by time and revealed by erosion. These stones remind us that some of the rarest beauty doesn't glitter in a world obsessed with what sparkles. It grows, it falls, it waits, and if conditions are perfect, it endures in gemstone form. Let us know which resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.